Right. See, we have more and more people joining in. It's great to see. It's 5 o'clock, so I'd say we kick it off. This is a screen recorded session, so in case you have to leave earlier, this session will be available online afterwards. But first off, let me welcome all of you guys. Thanks for being here to our webinar session about machine learning. Very exciting technology. And how it's being used in aircraft MRO and bringing innovation into aviation. Very exciting topic. Yeah, there's a future full of possibilities for this technology, especially for airlines and MROs to perform inspections and in a smarter way and really get actionable insights. So what will we talk about today? We will learn something about machine learning, about the technology itself, what it is, how it works. We're going to hear two very exciting and interesting use cases, but more on that later. What it means for the workforce and the current way how aircraft inspections and borescope inspections are currently performed. We're going to have a bit of a discussion on that topic, what it really means for the industry and for the future moving forward, as well as to talk a little bit about the challenges that come along with this technology and how we can overcome them. So I'm very excited about our two speakers today, Bart and Julian. Yeah, I think without further ado, let's give Bart and Julian the floor. Julian, do you want to give a quick rundown about who you are and what you do?
Yes, sure. Hi, everybody. I'm Julian. I'm a machine learning software engineer at Mainblades. I'm working here for 3 years now. In general, maybe machine learning software engineer is a little bit a too narrow description or too narrow role title of what I actually do. I'm actually in charge of the whole complete vision of how we approach machine learning at Mainblades, implementing the backend stack, front end, UX, UI integration, all of these things together. Yeah, and in the last 3 years, we have been working a lot on improving our machine learning stack using some tools that we will talk about in this presentation. So I'm really excited to talk about that. And yeah, I'm also really curious what our colleagues from Aiir have to say about this. So I'll hand over the word now to Bart.
Thank you, Julian. Bart Vredebregt, I'm one of the co-founders of Aiir Innovations. Unlike my titles is suggesting, I actually have a background in artificial intelligence. Did my master's there back in 2016. I think we finished 2017, already quite some time ago. But since then, we founded Aiir Innovations and actually managed to build a company around the technology. Now, more on that, what we do in depth later. Nowadays, I actually don't program that much anymore. However, I do get the opportunity to talk to a lot of different people from the industry to actually explain to them, hey, what is actually going on with AI? Why is it so important that you step on board on time? But also, what shouldn't you expect from it? So I'm really looking forward to having this discussion with Julian today, and hopefully everybody will learn a lot of new things today.
Fantastic. Great. Thank you so much for that. Hey, speaking of that, can you give us a little bit about a bit of insights on what your company is actually doing and the challenges that you guys are solving?
Yeah, perfect. Oh, we have the slide open already. That's even better. So at Aiir Innovations, we are focused on the borescope inspection. So the borescope inspection, you have to imagine once every 6 years or so, you take off the engine and you want to see, hey, what is going on? You do a walk around and on the outside, check all the parts there. But you also want to do it in the inside. And then you run into the issue that it takes a really long time to open up the engine. So people use a borescope, kind of snake-like camera that you can insert into the engine so that you can see the inner workings of the engine. So on the bottom right, you see an example of a turbine blade, and you have like 1,500 of those in an engine. So to inspect them all, it's super intense. You basically stare at the screen for, what is it, 8 to 16 hours, which leads to basically what we call human error. It leads to inaccuracy, inconsistent results. And to top it all off, you need to draft ton of paperwork for it to get it all sorted out. So what we at Aiir are building is both a software platform to make your borescope inspections as easy as possible, as well as using AI to actually automate part of the process, such that you have this kind of digital safety net for your inspections. So we're not automating completely. We're saying, hey, we are your assistant in that case. And we have the opportunity to work on this this far with parties like KLM, MTU, EasyJet, you name them. So we're really getting some first traction, but also learning a lot of lessons along the way.
And how do these inspections are performed normally nowadays?
Sorry, come again?
How often are these sort of inspections performed nowadays? Like on what sort of scale are we talking about this?
Yeah, so depending on the moment that you perform the inspection, so for the so-called off-wing maintenance, what you see here on the picture, that's one every 5 years or so. However, if we look at on-wing maintenance, where you also do these inspections, then it can be up to twice a year or even further, more often if you encounter a bird.
Right. Interesting. And so how exactly do I have to imagine it? So there's an algorithm sort of understanding, okay, there's a certain damage, and it's basically based on the input that it was fed to before. It's understanding, hey, this is a certain type of damage and it requires a repair. So the engineers can sort of directly take action based on this information.
Yeah, you explained it perfectly, so I don't need to add too much on it. But yes, in a nutshell, it's analyzing lots of video footage, searching for that one defect. On average, of all the blades that are in there, about 0.5% of the blades only has a defect. So you have to imagine you're literally searching for a needle in a haystack. And that's where AI can really help out. Searching for that one thing where humans just easily overlook it and can use the help of the computer.
Interesting. Yeah, I think Julian will also be able to tell a bit about that in a moment. But I think with machine learning, it requires a lot of data, right? It needs a lot of input. Can you give us some info on that? Like how much data are we talking about? What sort of data?
Yeah. So for us, our input data is definitely just video. It's video recorded by the borescope. Right. Actually, to annotate it, we have our software perform some automated reporting, as we like to call it. And that way we collect annotations on that data. What I think is the beauty of it is that now we reach the point where we have literally thousands of hours of video, such that you reach the amount of findings that you need to actually train proper networks that can learn a lot.
Yeah, interesting. Before we move on, I want to I forgot to mention during my introduction, by default, that is meant to all of our attendees today, by default, your camera and your microphone is turned off. But I really encourage you, if you have questions, if you would like to join a discussion, I really encourage you to raise your hand. You can do this here in this interface in Microsoft Teams. I will notice that, and I will be able to actually allow you to turn on the camera and the mic, and you can get to ask questions and join a conversation, right? This is an interactive session, so we really want to make sure that this function is also used. And I right away see a hand right there from Suresh. That's great. Thank you. Let me turn on the camera real quick for you and the microphone. Hello, Suresh. Thanks.
All right. Thank you for giving me an opportunity to ask a question. So my question is really around the borescope inspection, what you mentioned. Is it, I know there are, I work for MRO industry, and I know that there are some conventional instruments, equipments which are used, the videoscope instruments. So is it like you're coming up with a new set of instruments to complement that, or does it aid the current way of doing the MRO inspection?
Actually, the latter. So we are connecting with the existing borescopes, the videoscopes, as some people indeed call them, such that we can make them intelligent. So whatever borescope you have in the shop, we can connect to that and then actually attach our algorithms to it, such that we can basically enhance your workflow. Yeah, that should answer your question, I think.
Thank you.
Great. That's exactly what we want, guys. So if there's questions, don't hesitate to raise the hand. You got the experts right here to answer them. So that's fantastic. Great. I think we can move on. I think Julian will tell us a little bit about what we do at Mainblades and the potential of machine learning for this specific application.
Yes. So let me just before I start. Even though we have blades in our name, we don't do anything with turbine blades. That's Bart's department. But jokes aside, so Mainblades is a inspection MRO company. We focus on aircraft inspections with drones, fully automated aircraft inspection with drones. We're talking here about general visual inspections that we do usually when the aircraft is on the ground during a maintenance session. So before or after a maintenance session. So yeah, these inspections also, maybe many in our audience know, take a lot of time. It takes also equipment. You have to gather cherry pickers, scaffolding, set it up next to the airplane. It's dangerous because like people have to operate in certain heights above the ground. Usually these also take place in the night because that's when the airplanes are available. And again, as Bart said, there's a lot of room for human error and human inconsistency. And indeed, it is resource intensive. So these are the three big problems: time, human errors, and the resources needed. And yeah, with the dawn of the drone age, let's say, where we have super high performant drones that can stay in the air for 20 minutes or more, that can take payloads of several kilos. We have the opportunity now to like do these kind of inspections in a way shorter time, safely, with high quality sensors like high definition cameras. Use all the data that we get from the drone flight to create a report, including automated classification of damage or detection of damages with the help of a machine learning or AI algorithm. And we also have user interfaces that help our operators, our customers, to have insight into the inspection itself, insight into the results of the inspection, and so forth. So
can you share a little bit about what your day, a typical day at Mainblades looks like for you as a machine learning engineer?
Yeah, sure. So my typical day is, because I'm my main job is indeed engineering. We usually start the day with a general team meeting, and then we branch off in our own tasks. A lot of my tasks are now concerned with the processing of the data of our partners, because we want to use past data, so not necessarily images in this case, not necessarily only images from our drone, but also from from past reports, past inspections that we can use to basically jumpstart our machine learning algorithms. So I'm currently using that, processing that, building evaluation pipelines so that we can have like a very, and this is very important, evaluation. We will come back to that, so that we have a good, high quality assessment of our algorithms, so that we know how well they perform, so that we can also communicate clearly to our customers what they could expect from this and where the risks are, and these things.
Great. We see here on the slide a little bit of a sneak peek about the app, I think, where you are also as an engineer involved in a lot. Can you tell us a little bit about what we're actually seeing here on this app? Like, how exactly does the algorithm really work on a photo, let's say? Like, what is it actually showing to the engineer at the end of the day?
Yeah. So this screenshot that you see here on the bottom right of the app is actually already an outdated version. We're developing very fast. So what you see here is an older version, because in the meantime we have introduced a full screen mode. But still, you can also, but this is basically the basic view for a viewpoint, and a viewpoint is a point in which the drone has taken a picture, or of which a drone has taken a picture, and it's basically a certain spot on the airplane, and it will show you, and you see the picture is central here in this screen, and you see if there are some kind of damages in on this picture, and you can also locate them within the structural repair manuals conventions. So it would say station, maybe, so what does it say here, 807, and then stringer such and such.
Right.
So that we can also use this for a later repair, that we don't have to translate, like manually translate this data again into something that then, you know, the technicians can use to do the actual repairs. And also it's, for now, it's also an indicator to, so that the person that checks these reports, checks the inspection itself, and we will come back to that, can also go there physically, have a look again and say, okay, this actually makes sense. We're happy with this. We accept this, and go like look at the next picture if there's something on it or not. Yeah.
And what would be some typical use cases for a drone in the hangar? So for what type of inspections are we talking about here?
Yeah, it's usually, so we have different use cases. For example, aircraft leasing companies, they want a complete assessment of their assets when they go out and come in the door, right? They want to know what happened in between to them. They want to know, did the value of my asset decrease because of some kind of incident? And of course, the people they lease to, they might not report these things, or they might have overlooked something. So that's why they have a big interest to like have a complete, like, full body inspection of everything. And yeah, this is of course a very time-intensive kind of inspection. But on the other hand, these kind of inspections also don't happen very often, because the aircraft doesn't change hand that often. But however, before every, so we have also partners, MRO partners, that inspect the aircraft generally before, or I don't know, before or after every maintenance check they do, or check they do.
Yeah.
So they do it either before, but they always do it. And yeah, if you have hundreds of aircraft that you inspect per year, right, then yeah, you will need this almost every day, right? So these are the kind of use cases that we have. And of course, then there's certain special cases. For example, after a lightning strike, lightning strikes are challenging because they're very small, and it takes a lot of time and a good eye to find them. So that is also where our system can come in handy. You know.
Right.
And usually in that case, the inspection is done immediately. The aircraft is taken out of service, and we do the inspection immediately to find the issue. And yes.
Interesting. And I can imagine when the aircraft is really, there's a lot of photos being taken of the aircraft by the drone. Where do all these photos go? Where are they stored?
Yeah, so everything that we do is stored in the cloud. It's in a safe and secure location on the cloud with well-established industry players. The data is accessible from your organization. So imagine your MRO organization will use our systems. That means that every user that is signed up has your organization user email, has access to it. By the way, I just saw a comment somewhere popping up that we also need to do inspections for bird strikes. That's true, but usually with bird strikes is you don't need like a high resolution super optical camera to like find them, because they're usually very visible. Of course, if that's not always the case, so in that case, always also the drone might come in handy here.
Interesting. I think there's actually another question from Victor here. He's asking, how can we actually create a data set to actually learn the model? So I think that's actually blending in quite well with the next slide. Like, what is the data actually based on? Like, how does the algorithm actually become smart? I think in Bart's case, he mentioned lots of videos. How's that for Mainblades?
Yeah, for us, it's basically we can learn from images, and those images don't have to be taken from drones. Ideally, yes, but it doesn't have to be. We have gathered basically our initial data set basically from manual images that people took with their iPhones or with their iPads, and then sent each other on WhatsApp. So there was like it was like a real pile of all sorts of images, and we had to like sort them out and index everything. And then, but eventually we managed to create a really nice initial data set. I would not use this data set for any kinds of evaluation purposes or certification purposes. I don't think we would get very far with it, but it already jumpstarts our machine learning model in such a way that it can already help with the labeling, it's already assistive enough to help us when we did an inspection to gather all the damages that are there. So what we can do now that we have this initial jumpstart, we can now like really ramp up the data acquisition process, and with our interface, with our iPad, with our web portal, just upload new photos and immediately get like an initial assessment of the ML, and we just have to click through it, tuck, and then we get new data very quickly.
Interesting. Bart, is it similar for you guys? A similar approach, or is it a bit different? Can you share some insights on that?
No, I think we have we considered the same approach Julian just mentioned. So all the customers that we talked to, among others, KLM, offered, we have years and years of borescope inspections and photos that you can use. However, the challenge that we were facing is that we really wanted to train the algorithm on video data to make sure that we have the temporal element in there. So we couldn't really use just photos to just train the algorithm reliably. So what we actually did is that we set up first a reporting tool. So a tool where people would just mark our findings themselves during normal inspection without the AI being active. Now we did that for a year or two, and nowadays we actually, for every inspection that's being performed by our customers, they get the AI feedback immediately. Based on that, they indicate whether something is a defect, yes or no, whether it's interesting, yes or no. That way, we actually train the algorithm more and more, which allows us to do a lot more training than we ever imagined we could do. And actually, it came to the point that we are now actively removing AI findings because the AI is just generating so much data, and the challenge is to find the high quality data to train the AI.
We're going to see a bit of a simplification of exactly that point with the panda example in a few moments. I think that's bringing that point across also quite well. Just in between, guys, is there any questions from the attendees? Is there any questions that you would like to address?
I'm seeing a lot of questions in the chat.
The chat. Let's have a look. So I see here a question from Shikalu about, can the drone be integrated with a laser scanner to locate changes on the fuselage and compare old data with new ones? Do we have?
Yeah, I can answer that.
Yeah.
We actually do have a laser scanner already on board of our drone. So this is actually already happening, and exactly for that purpose of locating damages. And also measuring their size, because our drone knows very, very well where it is. It will. So we have a pre-recorded model, 3D model of the airplane, and it basically continuously matches its own environment in terms of laser range pings with that 3D model, and by that it can really locate itself quite well. That means that we can also, if we know where we look towards, we can also locate basically every pixel in our image, in our photos that we take, and that's basically what we do. And we can also measure like distances. We cannot measure depth yet, so depth of a dent or something similar like that, because the resolution of the laser would be, would need to be very, very low. Was it correct? So really, really fine resolution. But that is currently not possible with the system that we have. But we can also, and what was also very important is that we can cross-compare this with past inspections. So we have findings from a past inspection and a location. We have a current inspection, and then we can basically compare, hey, is this finding, has this been there before, or is this a new one? And we can log it in a sort of a time log of the whole aircraft life cycle log in a way.
It's actually interesting that you mentioned the life cycle, because that's something people don't really realize as much, that in the old days, or the current approach commonly, usually inspection results are not that consistent. So actually going back in time isn't really reliable. And with techniques like the drone, or for us, the borescope inspection that we make intelligent, you can suddenly actually do that kind of things, that you can go back in time and just know, like, okay, hey, if this is the first time it pops up, it is really the first time it was there, and not just it was missed the last time, which is really nice to see.
Right. So, but that still means also that the human, in a way, is still kept in the loop, right? It's essential to not just leave the AI to itself, basically. So I think can you, Bart, tell us a little bit about, okay, so how is this actually concretely reducing the amount of time spent for such an inspection? So in your case, for the borescope inspections.
Yeah. I see that we lost Julian in the process. So let me actually, there he is.
Yeah, I'm back. Can you hear me?
Yeah, we can hear you perfectly.
Okay, good.
So I think for us, the time saving is actually not too much in the AI portion. Yes, you can save time by making sure that you don't need to remeasure the same finding over and over again. So you have this thing called repeat inspections. So there you just need to check in on this finding every time. If there are 5 dents there, you just need to do repeat inspection on one of them. Then it's nice to be able to say, oh, hey, I already found these ones before. I know how big they are, and it's fine. But the biggest one is actually in reporting, typically for us, the time saving. So what we've seen is that for some inspections with a lot of defects, it can actually be the case that people spend up to 10 hours just making Word reports with all the photos and all the documentations in there. And that is something that the computer can do way easier. So we're actually right now working on this, what we call assistive reporting feature, where we even process manuals automatically for you, so that you can do such an process in merely minutes instead of hours. And then it's just reviewing what was generating, and you can go forward. But maybe I should explain what's on the slide as well, or can Julian do that? Oh, you're muted.
Yeah, sure.
Tell us a bit about how is it currently done, and where do we want to go? Where do we see it going towards?
You mean for the visual inspections, the general visual inspections?
Yeah.
Yeah. So how it's done now is, I think we mentioned it already a little bit. The aircraft comes in. It usually has to be towed to a hangar. Then you set up all these scaffolding, the cherry pickers, etc. And then usually people start climbing or maneuvering the cherry pickers around those aircraft. And that takes a lot of time. Afterwards, they have to write down, they usually take manual pictures. Afterwards, they indeed write down what happened. They send maybe an email with an attachment of the photo to someone. And yeah, it depends a little bit on the kind of organization or the kind of inspection they are doing, if this will get actually formally reported or if it doesn't. So there's a lot of inconsistency there. yeah, an inspection of a 747, it can take a whole night. It can take like the reason why I know this one is because I've been doing that with someone, like joining them on the cherry picker, going up there, and yeah, and it can take for one person, it can take a long time, up to 8 hours, and the drone can do this in less than an hour. It depends a little bit if you want to like how far you fly from the airplane, because sometimes the focus can be a little bit different. You want to just have a general picture, then you can do like more area per photo. But where we want to go to is that the drone does this in a short flight. You still have to review a lot of images. There's no going around that. But we will have an assistive tool indeed that will suggest which images to look at, and the human reviews that, and yeah, we use then this, the same interface, same software that the human uses for analyzing these damages, or the operator that is conducting the inspection. The same tool then generates this report so that someone else at a completely different location anywhere in the world like has it immediately available. So so a use case that we could think of is that basically have a specialist who is responsible for several locations, and they get basically these inspections sent to or shared within our front ends. They don't have to be physically present at any location. They get this from their colleagues on the ground, let's say, that are working on the front line, that are operating the drones. So I think it's also a way of more efficiently allocating your labor, your special, your specialisms. So this is what we envision in the future. Until eventually, we fly our drones in between flights on the gate, and all the reports are generated automatically, but that's a long time off yet.
Yeah, so it seems really that the whole machine learning part really is a key ingredient to that tool. You often hear words like AI, machine learning, deep learning, neural networks. Can you maybe also for the audience clarify a little bit on what the actual difference is here, and how that really relates back to the work that you're doing at Mainblades?
Yes, I can do that. Yes. So the term AI, artificial intelligence, is used a lot. It sounds very fancy, and it's basically a technology that does any kind of advanced operations that we perceive to be similar to what a human could do. Right? It's very broadly defined. It's not really exactly. People are really also fighting about what AI actually means. So it is, from a technical perspective, it is more very more helpful to actually talk about machine learning and deep learning, because those are a little bit better defined. Machine learning means we have an algorithm, so some kind of computer software computing system that performs a certain task, a specific task actually. So it cannot do anything or everything, but it can do a specific tasks. And the way it performs that specific tasks is by looking at past data. That's where the learning part comes from.
Right.
And then we have deep learning, which is a subset again of machine learning. If you could go back to the previous slide. Deep learning, which is a subset of machine learning, where we use deep neural networks for the analysis of our input data. And deep neural networks are the current state of the art. So there's, I would say there's nothing that works better in a lot of tasks than a deep neural network. So, like you can think of, image recognition, like face recognition, natural language processing, which is translations. Google Translate completely is switched over to NLP. It used to be something else, but I don't know what it was before. But these kind of things are really taken over by deep learning nowadays. Yes, and I think for both our companies, deep learning is the core of the algorithm. Yeah.
Do you agree, Bart?
100%.
Cool. So how does it concretely then? Okay, so now we have a bit of an idea on what it is, but how does it actually work, like concretely? Like what input is being fed to it to make it actually learn?
Yeah, so yeah, this is a very simplified depiction of yeah, what a learning algorithm does, or in this case, actually a classification algorithm. Classification means I have categories and I assign my input a certain category. And in this case, the category is, do we have a damage, or don't we have a damage? The input data is, in our case, images. So you just feed it, I don't know, a HD image coming from the camera. So in our case, it's a single image. In Air's case, it's a video, so a sequence of images. And then we have a computer vision algorithm, which is based on deep learning, that processes these images. And basically what it does is we have a network that basically looks at every pixel. And these network consists of stacked layers. Maybe this is a little bit too detailed for some of the areas, but there's a stacked sequence of operations that combine pixels in a way to investigate their mutual, information. So if, for example, if I have a crack in my image or on my turbine blade video, you will find a correlation between all the pixels that make up this crack, and this will trigger some parts of our network, which will then say, okay, we have a damage, or we have no damage here. And it will also tell you, in our cases, it will also tell you what kind of damage it is. So, for example, this is a crack because I see this long, elongated sequence of pixels next to each other, which are darker than the rest in a way. So it's very simplified, but that's essentially how you can picture it. And then you get this decision, is it a damage or is it a no damage? And in reality, this is a little bit more nuanced because you might be somewhere in between, I'm not sure exactly, but for the sake of simplicity, we have omitted that case. Yes, I think this is a good point for maybe additional questions.
Yeah, exactly. Guys, is there more questions from the audience? I see we have a couple of things here also in the chat. I'm also encouraging you guys to raise your hand and really be part of the conversation. It's meant as an interactive session, so should there be any more questions, really make use of that function. I see, yeah, actually I see a raised hand right there. One moment. I see Robert has a question. Let me turn on your camera and microphone. Hi, Robert.
I'm from the car, so apologies for the noise. So interesting presentation. I just have a question for you guys. Like in terms of collaboration with the OEMs, have you been able to access any of the data? Because sometimes OEMs, they have these conferences, at least at the end of the conferences, they have the conferences and they show images of typical image data and things like that. And have you been able to kind of get access to that information? And also, like, have you been feeding that type of data to your AI learning system?
Thanks for that.
Yeah.
I can share Air's experience with it. So for us, really, OEMs are typically not really a big source of data. Actually, airlines are the ones that are generating tons of data. Leasing companies are the OEMs. They only really get the most terrible images, and they don't really have the reputation of sharing that information as easily. So for us, it's really information from the field that's key here. Not sure how that is for Mainblades.
Yeah, for us, it's we have a very similar experience. We work together with the airlines, with the MROs, because they are the ones that use these tools and take the pictures, take most of the pictures. And it's indeed what Bart said. We've heard stories that, yeah, in the worst cases, or not in the worst cases, but in some cases where they're not sure what to do, they send it over to Boeing or Airbus, and then they ask them, hey, what do you guys do? What should we do with this? So, and indeed, they're not the best source of data. So we are working with our customers mainly that are going to use this product.
Thanks for that. I see another hand raised from David. Let me give you the floor. One moment. Hi, David.
Hey there, can you hear me?
Yes.
All right. This is David Petrowski from Delta Airlines. A follow-up to Robert's question. Machine learning, AI, and so forth. What have you guys experienced with acceptance of machine learning and AI by the regulators? Essentially, we're going to have to prove that it's equivalent or better than what we currently do. And while we know that, we're going to have to prove it with that. Regulators typically want to have, or they pointed out to me that the person initially programming and determining the algorithm is a human, and if that's a mistake, then how do you assure the quality assurance of your algorithm and so forth?
Thanks. I pass the question to both of you guys, I guess.
Yeah, I can maybe make a start. So if I understood your question correctly, you were asking what the input, or what basically the view of the regulators is in terms of the acceptance of AI in this industry. Is that correct? Yes.
Yes.
Okay.
And I guess that's an in general question, but it applies to both of these examples today, because you're using an image, you're applying some deep learning to those images to help you. And so it's kind of the same general overall concern from the regulators, or has there been any?
Yeah, so of course the regulators, they are not, right now they're not in the position of saying, hey, whatever you guys do, it's okay. We're gonna take it, we're gonna approve it, and you're good to go. But they are by themselves actually in a process of figuring out how to deal with these things. So the EASA has published a roadmap last year, and we're still in the initial pathfinding phase in that sense. So they're also trying to build up expertise on this in this area, which means that we are a little bit flying blindly here. But I would say there's already from the machine learning industry itself, from the also the research side, there's a lot of best practices of how to ensure these kind of how to tackle these kind of questions of reliability, accuracy. How do we evaluate that? In fact, a big part of my work is basically making a plan of having an unbiased evaluation system, and also a process. And what we're going to do in rough lines is basically we're going to, and this is in the beginning, it's going to be very labor intensive. So there's going to be a lot of work involved here. But basically we will have a human, or a usual, a conventional inspection that is then also done independently again by a drone, and we repeat that 10, 15, maybe even more, 20 times, and then we will see what are the differences. Are we actually missing things? And yeah, we hope that together with our partners that have some kind of punching weight in the industry, we can then go to the regulators and be transparent about what we have done, and then say, hey, this and this and this are the steps we have taken. We expect that we will do this well on visual inspections. Do you agree with this process? And then have them also, yeah, give feedback, etc. So this is basically the plan that we have in place right now. Yeah.
I'm glad that you guys at least have been invited to the table to how to try to figure this out.
Yes.
What I am worried about is the regulators, in order to make it easy for them, will do something rather silly and basically mandate a specific software version kind of thing. Basically invalidating the continuous learning kind of thing. Once you have an algorithm, they want it frozen in place and you can't deviate from that. And then they'll audit you to, are you using the correct revision? That makes it easy for them, but it really doesn't work for the industry and the operators. So, so please be aware, please be aware of that and keep fighting for that.
Yeah, this is yeah, very common way of thinking in the old ways, but it's totally not applicable anymore for if you work with data. So this is indeed a challenge, and we hope, yeah, we're trying to convince them that freezing the version of our model, or even freezing the kind of software that we use, is really not the way to go. So the way to go here would be a process of ensuring your reliability, which is transparent, which is insightful for the regulators, giving them access to what's happening. I think that is the way to go, and yeah, we hope that the regulators don't make it easy for themselves, but we will see about this. Yeah.
Yeah, right. I think we as startups will be able to figure out a way to make it work. It's not the end of the world if we are only allowed to release a version every year, for example. It would be a shame, but it won't be the end of this industry. Quickly, done, because we took a slightly different approach than Mainblade. For us, the focus right now, the coming 5 years, is mainly on assisting human as they are performing the inspection right now. And that way, it's never the AI making the final call, which for most processes and regulations is perfectly fine, as long as we keep human factors in mind to ensure that people are not blindly accepting what AI is providing them. And that could also be a way for the future to make this happen.
Right. Thanks, guys.
Yeah, I was maybe skipping a little bit ahead too much in this case. So for us, it's very similar that we have the final say is always done by a person. There's always someone who puts the signature under the report. Like literally, I think in our software we try to do that, to put a name and a date and signed by or approved by under it. So yeah, but for in the long term, yeah, we see it. We hope that there is some kind of framework present that will enable us to go even further than that, to go even further than assistive AI. Yeah.
Great. Given the time that we have already used, I think it's great the amount of interaction we have. Of course, it's stretching a little bit the time frame that we initially planned. So I think for now it's good if we keep going a little bit with the flow. So we learned a little bit about, okay, what is AI, how does it work? And I think Bart actually has quite an interesting story around the panda example on actually how to make it better. So maybe walk us through this. Who's the panda? What is the panda?
Yeah, the panda example. The panda example is one of the slides that I really love to use to explain the importance of evaluation and what you need to do with it. So for this example, we are looking at this image where you see all these snowmen, and there's one place there is a panda visible. Of course, that is something we all did in kindergarten and we were super good at back in those days. Nowadays, it would be nice to get some help from an AI. And that actually makes it quite easy to introduce some key metrics that we use typically in AI. And that are recall and precision. So recall, in the case of this panda system, would be the percentage of pandas that we found and of the pandas that we could find. So in this case, in this example, there's only one panda. So if you find it, 100% recall. Super. And if we, could you go back one slide? And then we have precision, which is an indication of how good the system is in just finding the specifics. So the percentage of findings that are actually pandas. So the next slide that was already shown briefly is a good example of where recall is perfect. So we found the panda. However, the precision is terrible. And a system like this would not really help any human. So we need to figure out the way to do it better. So one might say, oh, hey, let's then optimize for precision completely. So then we get what's on the next slide, where we have 100% precision basically. But our recall is 0, because if we don't detect anything, we can't make any mistakes. So it's all about finding the right balance between the two. And as you can see on the next slide, actually a system that has pretty good recall, but mediocre precision could already be helpful. Because if I now ask you to have a look at this example, now everybody should be able to point out where the panda is. So this is a moment where you can realize, okay, an assistive system, so where the AI is helping the human, might actually be better. So on the next slide, we actually did the calculation. So then suddenly you would have this perfect system where recall and precision are 100%. Which leads to, I think, the message that we have on the next slide is that in the long run, human and machine are stronger together. So you need the human to in the loop there. And that can take all kinds of shapes and forms in practice. So I think this was the example that this is indeed the slide with keeping the human and in the loop isn't a bad thing. So I think both of our companies are trying to keep the human involved, because we know that AI on its own is not perfect. Humans on its own are not perfect, but if we bring them together, we can achieve the best possible results that are achievable right now. Of course, in the long run, it might change. In the long run, it might be the case that you can do it fully automated. But for us right now, keeping the human in the loop isn't a bad thing at all. It's actually making sure that we can do innovations like this. And that might kind of look back to David's question. Hey, how do you handle the regulations? This is one of the ways, by keeping the human in the loop. And God.
I think we have another raised hand here, if I see that correctly. Let me check it real quick. David, your hand is still raised, or is it raised again?
Sorry, guys, I didn't put it down. Go ahead. It was the same.
Cool. Julian, do you have any take on this one? So because I think a lot of, let's say, concern that we receive often is, hey, but what about the engineers that are hardworking and doing already a great job? Will they be replaced by a drone eventually? Is that what we are heading for? That's a common concern that we hear a lot. What is your view on that?
Mm-hmm. Yeah, let me come back to that in a minute. First, I want to say that coming back to the previous slide, maybe you can go back.
Yeah.
Now that we have this feedback loop, maybe one slide more back, please. Now that we have this feedback loop from your final output back to the improvement of our algorithms, that means that this whole thing also becomes a problem for the user experience, the user interaction. So how do you make an app or a front end or a piece of software that is intuitive enough so that this is basically effortless, that this feedback happens effortless. And I think this is a great great reason to choose our software, because this is basically what everything evolves around, right? If it's easy to look at pictures, create reports, maybe correct a little bit the damages or what your findings are, save it, recall it later in our apps, then it doesn't really matter if you have good AI or not, but or if you like have the super high precision recall. But if the interaction is happening effortless, then we can automatically improve over time. Okay, now coming back to the question that you had, will people be obsolete? We don't think so. We think, for one, of course, this is still an assistive tool. So people will be able to do their tasks, but they will actually be able to do their tasks instead of having to climb, or instead of having to, manually copy paste images from their SD card into a Word document and sending it over. They can focus on looking at what they're interested in. They can focus on looking at the damages, at evaluating the state of their asset, their aircraft. So the labor intensive task will be shifted from in the hangar, climbing around, into looking at a screen. Unfortunately, this is how things work in the 21st century. But it will be a lot safer. It will be a lot more efficient. You will have a lot more reach in terms of the kinds of you will be able to see more assets in a given time, more aircraft in a given time. So we think that the labor is still needed. We think it will increase the productivity of our customers, also the safety. So there should definitely be no fear of AI is replacing our job. But the kinds of jobs you do, it will look different than 10 years ago or maybe 20 years ago.
How's that for Aiir? Require a special training to be able to use that tool, or do people need to go undergo a certain course, let's say? Like, just how does it look in real life? Like,
yeah, I think first coming back to Julian's answer. So for us, it's really similar. So our inspectors doing these jobs right now, our goal right now is to give them the best, what we call the best engine inspection experience, just making their life as easy as possible. Whether that is by fully automating it, making sure that we filter out all the blades that are perfectly. That is what it's all about in the end. So yes, the humans are still needed, and the part that we minimize should be the part that people find annoying. You shouldn't be removing the fun part of the job because, hey, you're becoming a mechanic for a reason, and that's because you love working with these machines, and not because you just want to get it over with as soon as possible. So for us to be your original question was, of course, what kind of training is needed before people actually using our software. We invested a lot of time in actually figuring out exactly, hey, what is the workflow right now for borescope inspections? We found, I think, 10, 20 different workflows that people were using, and analyze those and try to come up with the best workflow that people could use immediately, but also could immediately understand. And that way, we are standardizing the way people are working, while actually making sure that it fits the AI as well. And that actually, in our experience, is working really well. So it's making their jobs easier. It's typically faster, and the parts that are getting removed are the annoying part, not the fun part of the job. So that's exactly where we want it to be. I think the fastest training that we did so far was literally 1 minute, and it was a tech-savvy guy. We explained and where he should log in, and we just let him go, and he knew exactly what to do. the less tech-heavy people, we sometimes down with them for an hour, and they already get it completely, which is excellent. That's what you want. It should be as easy as just using your phone.
And how do people react when they see it the first time? Are they excited? Are they unsure? Are they to give us an impression on when they see this sort of technology for the first time introduced in their sort of day-to-day life? React.
I think you can roughly mention two groups. So one group is really excited, really curious to see, hey, what can AI already do for me? How can it help me? Another group is sadly scared or challenging in the fact that AI can actually do this. Which is why we should have discussions like this. Hey, what does it actually mean for people if AI enters a workshop or a hangar? Because there is a lot still unknown. People still believe that AI can take over everything. Well, that shouldn't be the goal.
Absolutely. Thanks for that. You have any more questions from the audience? Now is the chance.
Yeah, I saw some interesting questions in the chat.
Right. Which one in particular?
So there's one question, or I think several questions, if it's possible to integrate, so from Vinay, to integrate the defects into our ERP system.
Right.
So I want to shortly mention that we have this on our roadmap. It's not something that we have immediately, it's not something for the short term, but this is, we see this this use case. We see that we need to integrate it with external tools, third parties, because also IT departments are not very keen on having like several distributed kinds of tools scattered around. You know, you do for the visual inspections, you use the Mainblades app, and for the for the inside inspections, you use the Aiir app, and have like all these kind of different things used around. So we see the problem that it would be very, very helpful to have these integrated. So we're looking at that, but it's not something for the short term.
If I may quickly respond to that one. I think this integration with the ERP is also just another portion where we can make life easier. Actually, filling in your results of a report of an inspection is not fun. So we should automate it as soon as possible. Yeah, for definitely. Us, it's actually on the roadmap for next year to integrate with first ERP systems. And yes, it's a painful process for both the IT departments and the companies building the app. But the moment that it works, it's great. It's actually making life for everybody easier. And especially the people that typically would say no to innovations because they are afraid of technology, are happy with these kinds of changes because they don't need to open up this other ERP system. They just need one app that's built for their purpose, and they're good to go.
Yes, exactly.
Great question. Thanks for that. We're getting towards the end of our session here today. One last thing we want to address still is, okay, so we have learned a little bit about, okay, what is AI, how does it work? But so what are actually some of the barriers that hinder us from really moving it forward, pushing it forward right away, getting it into the hangar and have impact today? So what are some of these barriers, and how can operators and MROs actually help startups like us to overcome these obstacles?
Yeah, I think the first one, and the Japanese slide is the perfect one. It's sufficient quality data, and the best way to help startups like us with that is by actually using these tools, getting out there, allowing software or hardware to be used. Because only that way the relevant data is getting collected, so that we can filter out what is high quality. But also that gives us the opportunity to collect feedback from the field. So for us, demos or actual usage of the tool is the best way to just improve it every time, both on the user interface level as well on the AI level. So one of the lessons that we already learned when it started to be adopted was how super annoying some false positives are. So false positives are incorrect detections, and it happens with a super specific type of defect that always didn't turn out to be a defect. And the only way that we could resolve that was by collecting enough of those samples such that we can teach the algorithm that it shouldn't detect those. So sufficient quality data, definitely a big one.
Julian, you want to add on that as well?
Yeah, sufficient quality data is definitely one of the big challenges. But yeah, as soon as you get the process started, as soon as you get people on board, you will have at least the quantity, and then from there you select the quality. So that's really something that we look forward to really deploy this at different locations, different use cases, different MROs. Yeah.
Right.
So yeah, maybe the next part is ownership, and yeah, we recognize that this is like a really sensitive part of negotiations, because if I take a picture, is this my picture or is it the picture of the company that owns the airplane, or is it someone else's? Who owns these the picture? Also, when I start labeling it, meaning putting information onto that picture, who has the rights to that information? So these are questions that are still kind of open, and I don't think there's a lot of legal frameworks for these things. So yeah, this is still a challenge, and we hope that we don't get too slowed down by this. I would say.
Yeah. I think indeed the typical discussion that both our companies are having with customers is, hey, also what data is going into those algorithms? Is my data being used to train an algorithm that's used by my competitor? So for us at Aiir, we actually made the decision that we don't really train algorithms specifically for customers. We anonymize the data that we get in, and then we train one big model that everybody uses, so that everybody can get started from day one, but also everybody is profiting from using the tool as much as possible. Because in the long run, I think there is one key thing in aviation that goes above all, and that's safety. And the only way to guarantee that is making sure that these AI algorithms are as good as possible. But also, for example, if you do the evaluation of an AI algorithm, that the data that it's being evaluated on is diverse enough to actually be relevant. Because if if airline A only flies near the sea and airline B only above the desert, they will have different defects in engines, at least. So should they be allowed to just have their own AI certified, or should we just push everything towards one big AI model? And for us, the one big AI model is the way to go.
Yeah, for us, it's very similar. Yeah, we actually keep the possibility of actually training separate models, but just so that we can compare them and say, hey, well, it actually is better to use one big thing for everything. Yeah, but that's also one of the examples where we try to be transparent and show with experiments, showing by using the data in different cases how we made our decisions and how our algorithms work.
The last aspect that we mentioned here is rules and regulations and certification, certainly as well. How is that getting in the way of startups like us, like really getting this out there and being used and accepted as a tool?
I think for us, we already discussed most of it. So I'm going to leave this one to Julian because you guys have, I think, different challenges than we do.
Yeah. So for us, the challenge, of course, is that if we want to work with a commercial customer, they basically put the condition, but this is not something that I can use. This is not part of the regulations. This falls outside of the regulations. So as long as this is not part of the regulations, we will not use it. So there's this catch the chicken egg problem. So we need usage, we need use cases, we need data to convince regulators, but we won't get those if we don't have the partners that decline partnership because of missing regulations. So this is a tricky situation for us. Luckily, there are partners that want to team up with us, which we're KLM is one of them, Lufthansa Technik Philippines is one of them. We have others in the pipeline, but I'm not qualified to speak about that yet. So maybe Mike, do you have any more that we should mention here in this place?
Well, I mean, I think you nailed it already. With that example, I mean, one of the things for us is, of course, the Part 145 approval, that the MRO actually accepts this as an alternative means of inspection. Then we move on to the maintenance organization exposition. Of course, further down the road, we want to have approval by the OEMs as well.
Yeah.
Then also Mainblades is looking at outdoor flight. So as you can see, there's a whole ton of obstacles, let's say, for startups like this to bring innovation into aviation. But I think it is great to see, especially so close after COVID, that airlines and MROs are willing to take steps actually, and be willing to be open for innovation. And I think that's the most important part. Sure, innovation budgets here and there might be cut and it's difficult, but the first step is really the openness towards innovation in the first place, and looking at it and being willing to take steps with partners like us together. And I think that's the most important message also that we want to bring out today, that innovation is not possible. It's not a one-way street, especially not in a conservative industry like this. So I think it is in a way it's a positive note to get to the end to today's webinar. We have one more moment now for you guys to actually step forward. Should there be any questions, now is the time. We have the experts from both companies right here. So is there any more questions that remain unanswered? Any maybe you have a different view on one of the things we discussed today? That's also fine. Let us hear about it. Anyone? Any questions? Let's see. I think Jan Willem had a question. Training materials for students. Not sure if I understand this question. Not sure if our panel speakers do.
I can see the questions, so I have no clue.
Oh, okay. So the question is there training materials about AI, ML, deep learning for education for our technical students at MBO Collage Airport Airplane? That's a good question. Actually, it would be, yeah. So I don't have anything by heart now, but usually YouTube is a great information source about these things. Also, what my personal favorite is the Khan Academy. They have free courses about all the basic machine learning, basic math. It builds up, in the level of difficulty. As very well explained. They have a YouTube series. They have all sorts of other. They also have a website. But we don't have anything specific. Maybe we can find something, Mike, and put it also on our website, like educational resource. I think it's very interesting. Also that like people have this information available if they're looking for it.
Yeah. And to just add on that, in general, for us at Aiir, we do on a regular basis, we do guest lectures at, for example, aviation studies here in Amsterdam. So just drop us a message. Typically, we can spare a few hours to actually talk to the students, because that is actually also the way that we got started, because domain experts started talking to us. about this. So we're happy to return the favor. And that's the same for Mainblades as well, because that is what it's all about. Innovation should inspire, whether that's in the workshop or already at school. Maybe that's even the best moment to get started with it.
The earlier the better. Young shining stars. Ömer has a question. I'm not exactly sure if I understand this one. He's asking, is there any competent authority worldwide built or ready to build this infrastructure? Not sure exactly what you mean with this infrastructure. So of course I think maybe this is related to the regulation. So of course we have the authorities EASA and FAA, which I think really provide the basic framework. And then of course, at least for Mainblades case, there's every country has its own national aviation authority with maybe specific additional rules. So yeah, it always comes down to working it out on an individual level. Then yeah.
Just in case that he meant with infrastructure, the thing that we talked about with all the data being collected, that we should combine it. Of course, that are the companies ourselves doing. So we are building this huge data set for borescope footage. Mainblades is doing that for our drone footage. And that's, I think that should be a commercial thing, but independent of the airlines and MROs, and especially the OEMs, because that in the end kind of means that if you work with one OEM, sometimes you get in trouble with other OEMs not liking it too much. It shouldn't be one party putting everything in their own direction. Not sure how to say that correctly in English, but again, I hope you get the point.
So in a sense, it's a little bit inefficient that that every company, every startup is building their own infrastructure for this. And I think we would be very open for suggestions if there's a industry accepted standard on this. We would rather have the EASA telling us, hey, make your data set available for evaluations, instead of them telling us, hey, freeze your model now because we don't want to recertify it. So if there's some kind of industry-wide effort there to make this, then of course we would be very open to that.
Now maybe then this is the moment to actually get started on that together. Just joking.
I think we have one last question. I think then we can conclude this great session for today. We have Victor asking how much percentage of the budget of borescope machine learning project does the manual data labeling take up? Do you understand?
Yes. So I think his question is more about hey, if you would say we use old footage and we would label it by hand, then you would spend an insane amount of money on annotating. That's also why we chose not to do manual annotation, because that in the end is the most inefficient way of actually collecting your data, because you have a human checking a photo or video that was already checked by an inspector. So we have the inspectors that are reviewing the footage as part of their job, actually doing the annotation for us. And that is, I think, the way to go. Also because they are domain experts. So I think somebody suggested in the past that we should use crowdsourcing random strangers on the internet to annotate our data. We think that is a terrible idea. Of course, if you have enough people, it might work, but we rather have domain experts actually do annotation work for us.
Yeah, exactly. Using the domain expert and using them efficiently is, I think, the way to go, instead of having going for quantity over quality, let's say.
Yeah.
Yes.
And just to add on that, so if you would hire experts to actually annotate it as domain experts, you can in principle spend an infinite amount of money on it, because there is just so much data to go. So actually mentioning a percentage of budget, it's a choice.
All right, great. Thanks, guys. I want to thank everybody that was joining today for being here. I think we had a good talk. We had good engagement. I want to thank everybody being here. If you have any questions that come up in an hour, or maybe tonight when you sleep, or tomorrow morning, you say, fuck, why didn't I think of that? Why didn't I ask that yesterday? We've got the email addresses from Julian and Bart right here. So please reach out should there be any questions. But in any case, also I want to highlight that next week we'll be present at MRO Europe. Yeah, basically a huge influential MRO event taking place in Amsterdam. Both of our companies will be there with a booth. So I really encourage you guys, if you're there, drop by, have a chat with us. Actually, also Bart and one of our co-founders at Mainblades will be giving a short pitch and a talk, presenting a bit of a case study. Yeah, so if you're around, really drop by. And once again, thank you guys for being here. It was a pleasure. It was fun. And yeah, thank you all.
Yes, thank you.
Thank you.
Have a good one, guys. Bye.
Bye.
Bye-bye.